It's showtime. Hello. Um, hello. My name is Henrik, and today for my passion project, I'm going to be presenting about packet switch networking. I hope my mic sounds good. I'm pretty proud of the way that I've set it up. Um, so let's get going here. Let me set up my views and all this stuff. Uh, so let's go to the next. Make sure that it switched to the next. The history of packet switch networking. What is packet switch networking? Packet switching is the basis for all modern computer communication, as far as we know. So, all non quantum computer communication is essentially based off of packet switching by Donald Davies, who created it in NPL, and we're going to go over that in the next couple of slides. It works by taking your transmission, whether it be a document or an image, and splitting it into hundreds of packets. These packets contain a header with its metadata and a body that includes a parcel of your transmission. It was designed like this to allow for dynamic routing to reduce congestion. Dynamic routing essentially means that, like, you can, let's say, you can have those packets instead of just having one big chunk of data. If that big chunk of data hits a roadblock or it's congested, it just gets slowed down and you can't do anything about it. What happens with packet switch networking is that when it breaks it up in all those little packets, it can send it over multiple different transmissions, and that way you can have multiple packets moving at the same time, and therefore having them go faster. I apologize for the wind noise. I'm not trying to ear rape anyone, but yeah. It was originally created by Donald Davies, so let's go to who invented packet switch networking, or rather, yeah. So essentially, there was this man named Donald Davies who was the conceptualizer of packet switch networking. Um, he was a computer scientist who came from Wales. He held degrees in physics and mathematics, and he worked with great minds like Alan Turing at the British National Public Laboratory. He started working there in the 40s, stopped for a little bit, and then came back in 1966. Um, his team at NPL designed early computer systems like ACE, and the origin of PSN can be traced back to him. Why/for what was it invented? Why do we have packet switch networking? What um, necessity is the mother of all invention, as that saying goes. So what necessitated a computer communication? In 1965, many computer scientists had the same idea. We need a fast way to send messages between computers. In 1966, Davies returned to the NPL and became very interested in it. Davies and his team came Davies, meaning Donald Davies. Donald Davies and his team came up with the idea that many other computer scientists did. The fastest way would be to break up the data into bits so that we can improve reliability and decrease congestion, which is the same thing I addressed on slide 4. While the NPL was working on this, America's ARPA, or the Advanced Research Projects Agency, heard about it and happily received Davies' network topology. A topology is kind of like a map of how networking things are connected. And when ARPA heard about this, they were like, hell yeah, man. And so they decided to put that into ARPANET. So, the scale of the internet. So, let's start with early wide area networks, or WANs. The early beginnings of the internet can be traced back to ARPANET, an experiment created by ARPA, or the Advanced Research Projects Agency. The computer science division at the NPL in Britain tried to get the government to establish a similar WAN, but the government essentially said no. Um, the first computers were connected to ARPANET in 1969, and the ARPANET team continued development and connections until 1975, when the project was declared fully operational. It was then that the project was handed off to the Defense Communications Agency. The image on this slide is a map of all connected computers in 1974. This was created by this is an open source map created by a user of the internet, sourcing from documents, essentially public documents. Modern communication methods. So for this, I'm just going to go with email, um, because well, email was the first one, and email was the first kind of organized communication method that still exists today, and so I'm just going to go with that. Although there are many other types of there's texting and there's instant messaging, many other forms of those things. Um, there's voice over IP, which is like internet telephony, but email. Email is the most basic and widespread of all communication methods. The invention of electronic mail is credited to a man named Ray Tomlinson circa 1971. If you remember from the previous slide, this was smack dab in the middle of ARPANET's development period. When it was first invented, it was very basic. Users could only use ASCII characters in their messages. Some aspects of early email still hold true today, though. The biggest symbol is the @ sign, the circle with the little, well, yeah, the A with the circle around it. This was an early invention which was used to tell the computer where the email was to go. Example, the email is so and so at sign UCLA. So you have the person, the intended receiver, and the at what comes after the @ sign is essentially the address. So the computer looks at that and goes, "Oh, this I know where this computer lives on the internet," and it sends it over. Now we're going to go into the effect on the world. The early effect, 80s and 90s. So right around the 80s and 90s was when it started. Well, 1983 was the year that the internet party really kind of started. Um, this was the year that TCP/IP, or Transfer Control Protocol / Internet Protocol, was widely implemented across the network. This global, literally global, standard meant that any computer LAN or local area network connected to a router could adopt a WAN IP address and communicate with other computers hundreds or even thousands of miles away. This was also the year that Paul Makapetris invented the domain name system, or essentially the kind of the beginning of the .com. This is a really important step for the widespread accessibility of resources. What DNS basically does is convert the human-readable hostname, example, google.com, to a computer-readable IP address. As we know, it's a lot easier to remember a cohesive word or phrase versus a randomish number. Widespread adoption. At this point, many nations were getting connected and building lands for higher education purposes. So this meant you'd have a lot of universities and laboratories, national laboratories, private laboratories, connecting so that they can share their research at higher speeds. And they can also see what's going on with other experiments and how they could help, theoretically. As you can see, I have placed a graph on the right of the slide. The purple line indicates the amount of hosts connected to the internet from the early 70s up to circa 2018 to 2019. The amount of hosts being connected spikes during the late 80s and through the 90s, mainly due to people and foundations leading initiatives to connect continents like South America and Africa. Also in 1990, Linus Torvalds created Linux, and it became one of the driving forces behind open source software. So, Linux, as I was actually writing this, I never thought about where the name Linux comes from, but I do know that Linux is based off of a very basic computer assembly language type system called Unix, and it's also what Mac OS is based off of. And I just suddenly realized, while writing this, that in fact, I think Linus Torvalds called it Linux because Linus, Unix, Linux, whatever. Point made, Linus Torvalds created Linux and became one of the driving forces behind open source software. So, the effect today, you kind of know where this is going. Needless to say, the internet is the core of today's world. Over 95% of today's total telecommunication data flows through the internet. The onward march of innovation in hundreds of fields would not happen without the incredible collaboration tool that is the World Wide Web. Approximately 4.5 billion people, or 59% of the world, have active internet connections, yet there is still progress to be made. During the immense growth of the internet, the digital divide formed and still rears its ugly head in statistics, meaning that 40% of the world still does not have access to reliable broadband speed internet. The coming slides will display some graphs about that. So as we can see here, oh, let me go back here. So this is the first graph I'm going to show you, one of about four. This is digital around the world. So what we're seeing here is we have a like total population of 6.76 billion um, people. Unique mobile users is about 5.112 billion, so about 5.112 billion smartphones that are connected and online. This does not account for individual smartphone users, only individual smartphones, meaning that multiple people own multiple cell phones. There's about 4.388 unique internet users, about 3.84 billion active social media users, and so this could mean um, social media on phones, and so social media. This includes forum sites like Reddit, 4chan, and 8chan, those nasty ones. Um, Also, like picture sites like um, Instagram. You have other things like Twitter. This is everything. This is also like online chat rooms like Omegle, and so much more. Obviously, I'm covering less than 1% of all these websites and social media. So next, we're gonna move on to internet penetration by region. So this shows us like by internet penetration, that means just rearranging. Internet penetration means like how many people in that region have access to internet, objectively speaking. So this graph shows us this kind of reinforces my thing about the digital divide. As we can see, when we look into like Central Africa, the internet penetration there is relatively low. Let me just it's relatively low, and then when we go up to places like Northern Europe, we have a 95% penetration. Um, Eastern Africa has a 32% penetration. North America has a 95% penetration, similar to Northern Europe. South America, 71%, 72%. So as you can kind of see, it follows the curve of like GDP per capita GDP. The richer a country is, the more internet penetration there is. Um, because they can afford to spend more. The companies there have more money to spend telecoms, um, and so yeah, so that's kind of one of those things where you can see the digital divide rearing its ugly head. So this is internet use from a device perspective, meaning um, like how much like what do people use the internet from? So as we know, we have 4.388 billion active internet users. About 57% of the world, 57 to 59% of the world. These graphs are from January 2019 also. So this changed. This definitely changed, definitely gone up. The total number of active internet mobile users is 3.986 billion. So a lot of people are using internet on their phones because things like social media are very big. As a percentage, that is 52% of the total population of the world that accesses internet over a cell phone or other mobile type devices. So as we can see over time, internet growth, while while it may seem like the internet doesn't grow all that much really fast anymore, it definitely still does. Because we can see here, even since 2014, we've had like over a couple billion people receive connections to the internet and begin interacting on the internet. Um, and so that really shows. So this is a graph of average internet speeds over. So this is a graph of internet speeds. Um, this is another graph where you can kind of see the whole digital divide thing. So the highest on this graph is actually Singapore, because Singapore is essentially a city state. So they don't have, if you compare that to somewhere like the US, where we have a bunch of cities, and then there's a lot of space in between the Midwest where there's a lot of farming that takes place, and there's also not a lot of internet that goes on there. Um, Singapore is the financial hub of Asia. So obviously, when you essentially have a city state, the internet connection speed really goes up there. The average connection speed, because there's not a lot of farmland, low connection speed stuff dragging it down. Um, and there's also a lot better internet penetration there because then again, there are like it's a high density area. Um, and so that's kind of like when you follow all the way down the graph, it can get like kind of ugly. But and so for the last graph, we're going to say the world's most viewed websites off of source SimilarWeb. This website, so obviously we have our usuals. For the top three, we have Google, YouTube, and Facebook, which makes a lot of sense because those are some of the largest platforms. We have um, Baidu, which is likely an Asian site, because there are like India and China lead the world in active internet users, as does the U.S. And as we can also see in slot 8, there is also adult content sites. There's a lot of things. Reddit is in slot 20. Um, Wikipedia is in slot 5. Yahoo in slot 6. Twitter in slot 7. Instagram in slot 10. So it's a lot of stuff that kind of makes sense. But anyway, thank you. Um, so I guess that'll be it for this presentation. Um, we are looking at an image of a data center right now. You can see above all the fiber channels running through this data center, the security caging. But anyway, that I'm going to wrap up this presentation at a total length of 18 minutes, um, or a little less than 18 minutes. But anyway, thank you for watching, and have a good day.